Okay, let's check the. Okay, again. Here is the best concept how to know this. And when we change the purple ball, move it up, move it down, move it up, move it down. But you cannot move it to the left or to the right. You can only move it to the upside or downside. Why? And when I move the ball, we can see the line is moving up, moving down, and the number here is increasing or decreasing. Let's check this. When I move it up, 1, 3, 2, 4, 5, 6, the number here is increasing. When I move it down, 7, 6, 5, 4, 3, 2, 1, 0, then -1, -2, -3. Thus, we know the number, the location, the coordinate is the number here in the purple, and we can move the blue ball from the left to the right, from right to left, and there are two vectors to determine the left or right. The first one is the numerator. The second one is the denominator. So what's the definition? The definition of the slope is n. The n. So the representative is m. And now the distance in the horizontal direction is 8. For example here, 0, 1, 2, 3, 4, 5, 6, and 8. 8. The number, the distance from the y-axis, the distance is in the denominator. And we can move to the left when 8, 7, 6, 5, 4, 3, 2, 1, 0, then it becomes minus number, -1, -2, -3, -4, and the numerator become a minus number. Okay, thus we know one thing, we can move one data you just mentioned, you can move it up and down, you can move it to the left and to the right. Yes, but for the interception here, the purple, you can move it only up and down. Is it okay? And for this green line, the equation is y equals x. Y equals x is it goes through the point 0, 0. And when we select the line y equals minus x, then the slope is left is high, right is down, and it goes through the 0, 0 point. Okay, if you understand this, you can screenshot this one and write down the notes from your then 1 minute later I will move to the new one. Okay, I just sent the link to the line group, and the topic of this one is least squares regression, as we learn the concept from the chapter number 10, and here are some screenshots from the website, like this one. Okay, you can use this one on your cell phone. And remember, if we have some numbers like this one, 1, 2, 3, 4. Oh, it seems that a line very close to those 5 dots, and I can select the grid. Okay, what does it mean? Best fit line. Okay, let me explain here. The residuals, check it. It means for the distance from the x-axis, the point from the y-axis, the distance from the 0 to the location here, to the coordination here. Here is the residuals. And squared residuals, what does it mean? If I have this one, what does it mean? The square root, okay, let me, and now we switch to the best fit line. We can click here, residuals, and the squared residuals is a little different concept because we use the best fitting line. Why we need to learn the best fitting line, the linear regression? Because we want to predict an unknown variable. For example, if I got a number that from the x-axis is 12 here, and we have no idea if we got the input value 12, what we will get from the y value. We don't know that, but at least we have 5 points here, then we can get the equation after the calculation. The equation of this line, that is y equals 0.8x plus 2.24. So you can expect, if I have a value here, if I have, not this one. If I have a value that is x equals 12, what will be the y value here? Very easy here. Okay, where is my computer calculator? Okay, for example, if we have input value is 12, what will be the y? According to the best fitting line, the equation, we have y equals 0.8 times 12, then plus 2.24, and enter. We got the y value is 11.84. It means from here to here, that is 11.84. That is a prediction. Again, why we need to learn this? Because when we have some regression, we need to know, hi $1, the general manager asked us to have a plan to sell our product, but in the past we have some experience data here, and can you predict how much we need to input, and can you predict how much we will get? This time, the equation of the linear regression, the best fit line, the equation, you can calculate easily. Is it okay? And why we need the best fit line? Because the principle is try to find a line. For the line, the residual, the definition is the spot, the y distance to the line, that is the residual. And sorry, something wrong with the projector, because this one should be a square. This one should be a square, but when you project on the big screen, it becomes a rectangle. It's weird, but you can use this one. That's a square. When the square value, try to make the square value minimal value. Okay, then we can select 1, 2, 3, 4, 5. We get the square value. That's the smallest. So it's called least square regression, linear regression, like this one. Okay, how about 2 minutes? After that, we can switch to next issue. Okay, let's move to here. Okay, here is about graphing quadratic, quadratic. And now we can observe the curve here. The curve here is called y equals 1x squared plus 0x plus 0. If we set the a, the coefficient of x squared, increase it, decrease it, increase it, we can see that the curve becomes narrow, and when it becomes zero, it becomes a line, a horizontal line, and when the a becomes a minus value, the curve is facing down. The positive value, the curve is facing up, facing up. Okay, and if we change the b value, if I move it, the b increase, oh, the b decreases. Oh, interesting. Increase, decrease, increase, decrease. And how about moving C? Moving C, increase. Oh, the curve is going up. Decrease the C value. The curve is going down. The curve is going down. Okay, I think it's interesting if you forget the basic principles of math. Okay, how about 2 minutes finish this one? And I encourage you to screenshot this, then write down your notes. 2 minutes later, we will move to the other. We will move to this one. Okay, I'm going to share this. Oh, the topic of this one is curve fitting, curve fitting. And now we know one thing. We know one thing. If in the x-axis and and the y-axis, if we have only one dot, 1 point, that's 1 point. If we have 2 points, then we will find sorry, it's not so good. Okay, a line go through those 2 points, then we get the equation y equals ax plus b. That is 2 points. 2 points. And if we have If we have 3 points, 1, 2, 3, and we will get a quadratic line. Oh, sorry, not so good. Like this one, and that is 100% fit. For this one, that's 100% fit. And the equation is y equals ax squared plus bx plus c, as I demonstrated a few minutes ago. Okay, and the same way, if we have 4 points, we can 4 points. That will be y equals ax cubed plus bx squared plus cx plus d. So remember, always 4 points minus 1, that becomes x cubed. 3 points minus 1, that becomes square. 2 points minus 1, that is x to the power of 1. Okay, just a quick review for the high school math. And now we know one thing. Here. We can find here a spot or a point. If we have 2 points, then we can select linear and best fit. We get y equals cx plus d. Yeah, the same way as y equals ax plus b. And now we have the third point, and that is far away from the other 2 points. And if we do the curve, we do the linear, that is become very scattering. R square value becomes 0.51. That is not a big number. If I remove that 2 points with 1 line, the R square is 1.00. It means 100% fitting. 100% fitting. If I have the the third point, if I select quadratic, then it will become 100% fitting. Click here. Yes, 100%. R squared is 1. R squared is 1. No matter you move it, how you move it, it becomes a quadratic line. And the fitting, that is 100%. Sure, this moment, if I have one more spot, when I close to the original one, that is very close to 100%. But if I move a little bit to the right, wow, see, the R square is decreasing to 0.26. If this moment I select cubic, we know 4 points, 4 minus 1, that will be the power of 3. If I select this one, guess what? It will become 100% fitting again. R squared becomes 1. Let me click it. See, that is 100%. But the curve is a little bit weird because it's going down a valley, a mountain, then going down again. Okay, please use this one as a game for 3 minutes. Okay, the topic is where is it? Fitting, vector fitting. Okay, the curve fitting. Okay, 2 minutes. Okay, and okay, in our textbook, okay, in this textbook, we'll explore linear regression only. But actually, when I was a master's student, we did the logarithm linear regression. I transfer the number of viable cell count of bacteria into the log value. After that, I can do the linear regression for the log number of viable cell count to the optical density, and now in the future, if we want to find again, I may not have this one in our final exam, but I want to share a very important concept to you. In the future, if you want to find the relationship again, the regression, you want to know the correlation between two sets of data sets, two groups of values, you can do the regression. Again, you want to know, if you want to know the correlation of, for example, the body weight and the blood pressure, are there any correlationships between body weight and blood pressure? We don't know. We need to do the research. We need to select appropriate samples, patients or health people, to check their body weight and their blood pressure, and we can do the plot, draw the plot to watch those scattering situation. Then we know, oh, okay, maybe no correlation, maybe high correlation. For example, another case is, generally speaking, before the midterm exam or final exam, a student pay more time on studying, the student will get a higher score. We believe there is a positive correlation. Okay. And in the future, if you want to find the situation, my suggestion is here. Quadratic regression calculator. Yeah. In the future, if you need to find two data sets, is there any correlation between that one, you can select this. All this. When I was a master student and PhD student, we did the log. Okay, let me show you one possible way. For example, if I have value 2, 4, 8, 16, 32, 64, and 128. If I have something here, for example, 1, 2, 3, 4, 5, 6, and 7, how to get the regression? Actually, those data sets are very perfect, because 2 to the power of 1, 4 is the 2 to the power of 2, 8 is 2 cubic, 16 is 2 to the power of 4, power of 5, power of 6, power of 7. After drawing this, it will become very, very beautiful, and the correlation is very high, 100%. Let me calculate. R squared like this one, no, it's very bad. Okay, who can tell me? 3 minutes. If you can tell me and with a satisfied answer, I will give you extra bonus point score for this one. I mentioned I designed 2, 4, 8, 16, 32, 64, 28. And here should be 1, 2, 3, 4, 5, 6. Why? I expected that the line is very, very beautiful. But why the value is not so good? Look like this. Who can tell me? I have two possible answers, but I don't know the exact answer. But I expect two possible answers. Who can tell me? 3 minutes. Raise your hand. Why? Can you design a set of numbers and fit it, and we got R squared 1.0? 1.0. But now R squared is 0.5. That is not high. First one, you can use my number, very similar or similar number. Second one, tell me why. Either one is okay. I will give you extra score in the end of this semester. My question is, I designed this one 2, 4, 5, 2, 4, 8, 16. You know, that is 2 to the power of 1, 2 to the power of 2, to the power of 3, 4, 5, 6, 7. And I expect 1, 2, 3, 4, 5. The correlation after the logarithm, that is becomes very high. But why I got the very low correlation, just 0.5? Can you find a set of number similar like mine? How about if you got that, you can type on online group, I-Yuan, I have some idea. Then I will go to your desk. Then you don't need to tell other people. Two possible ways to solve this question. Originally I expected I will get, because there is a beautiful data set, I expect to get the R squared is 1.0. It means 100% fitting. But I didn't get it. Why? Two possible reasons. How can you? I expect the R squared value is 1.0, but the correlation is 0.5. That's not high. Okay. Okay, let me screenshot this one to you. Then we will have 10-minute break. Okay, how about have a 10-minute break? Then tell me why after 10 minutes.